In this video, I will be talking about Introduction to Machine Learning. Particularly, we will understand what is machine learning. Well, it is important to start with the definition of machine learning. Machine learning is a field of study which is completely dedicated to give computers the ability to learn on itself without being explicitly programmed. What do I mean by this? We will look at some examples to understand this better. But a few more points about machine learning are, it is completely data driven approach. That is, a machine learning model would look at lots of past data and it will learn some patterns present in the past data. The model would be trained on the past data, and in that process it will identify certain patterns, and using that patterns it would predict the future as much accurately as possible. Can you think of any good example for this? Well, how about a model which will predict, let's say, Microsoft stock of tomorrow's price? This is an example of a machine learning task or a machine learning model which probably has seen 6 months of Microsoft data in the past, and from that past 6 months of Microsoft data it is able to identify and predict tomorrow's price with a certain accuracy. That is a good example of machine learning. But let us look at some more examples. Now I want you to identify, do you see a pattern in this particular sequence of numbers? And if you see a pattern, can you predict what is the next number? As you can see here, the next number would be 12, because there is clearly a pattern where 2 is added to the previous number. That is, the next number will be always equal to previous number plus 2. That is a very simple pattern, as you can see here. Now, as a human, we were very easily able to identify the pattern in this kind of a data and also predict the next number. But sometimes it is not always straightforward to identify the pattern. Let us look at a little bit more difficult example. Consider this sequence of numbers. Can you identify and predict what is the fifth number in this sequence? Well, it is a little bit difficult but not very hard. If you look and spend few seconds of time, you will be clearly able to see that this is the pattern. The next number is 2 times of previous number plus 2. By this logic, the fifth term would be simply 62, right? Let's look at one more example. The data can be a bit more complex where there are many variables involved. For example, I have x variable and y variable over here. Let us say y depends on x value. In this case, do you identify any pattern? Is there any relationship between y and x? If you have identified it properly, it is clearly y is equal to 3x plus 4, isn't it? Now, if this is the pattern you have identified, can you tell me what is the value of y when x is 7? Well, since you know the pattern, you can simply substitute 7 in this x and identify that the next number is simply 25. This would be 25. Now, let me ask you an interesting question. Can you automate this process? That is, I don't want any human intervention, or I don't want a human to constantly use pen and paper and calculate and give me the answer. Is it possible to automate this process so that I simply give a number as an input and I would get the output as expected? Well, it is completely possible. Yes, it is possible. For example, I can write the logic in Python code, and let us say this is that logic. I have defined a function called ABC which will accept an input called x, and this is the logic I have written, which is simply the pattern. Y is equal to 3 into x plus 4, and I am returning y. Now, if I pass 7 to this function ABC like this, x is equal to 7, simply ABC method will be invoked and this 2 lines of code will be executed, and I would get the output as y equal to 25. That is, I have written this logic once, let us say in Python, and I can execute this logic as many times as I want in Python and get my desired output because the logic is already written. So this is an example of me explicitly writing the logic in code. It could be any programming language such as Python or Java, but I have explicitly written the logic and I have automated the process. Tomorrow, if I want to know what is the value of y given x is equal to, let us say, 32, I do not have to use pen and paper and then do 3 into 32 and then plus 4. I will simply pass x equal to 32 to this Python file and it will give me the output of y. This is simple automation. Great. Now, where does machine learning come into the picture now? Let us see a little bit more complicated example, a little bit more complicated data. For example, do you see any pattern over here between x and y? Can you recognize the pattern? Well, it is not that straightforward. It is little difficult to identify, but definitely if you spend a few seconds of time, you will be able to identify pattern. But let us say it is difficult and you are not able to identify the pattern due to some reason. Okay, if you don't know the pattern, can you tell what is the value of y given x is 7? Obviously you cannot, right? Only if you know that logic or the pattern or the formula, you will be able to correctly tell the value of y. In this case, let us say you were unable to identify the pattern, therefore you cannot tell what is the value of y. Now, if I ask you, can you automate this process? Can you automate, let us say, this particular logic and then given an input, can you give me the corresponding output? Answer is no, because we were unable to find the pattern, or let us say it is very hard to find the pattern, right? But what if I use a machine learning approach? Now, in a simple software engineering approach, as you can see here, I do not know what is the logic to be written. Therefore, given an input called 7, since I do not know what the logic is, I do not know what the output is. Therefore, I am unable to automate because I don't know the logic. And in real life, there are many such situations where it is very difficult to find the pattern present in the data by a human being or logic present in the data, right? In such cases is where machine learning will come in the picture, which is capable of identifying the pattern much more better and much more faster than any human being. For example, let us say I will write the code of a machine learning model. Okay, what is this machine learning model? We will get into that in the further classes. But a model is something which can simply look at the past data. As an example, let's say over here you can see, given this input, this is the output. Input is 4, output is 31, input is 5, output is 42, and so on. This relationship will be learnt by this machine learning model, that this model is seeing that when x is 4, y is 31, x is 5, y is 42, x is 6, y is 55, and so on. And this model will use some mathematics in the back end internally. It will use some approach and it will be able to come up with the logic as much accurately as possible. In this case, which is nothing but y is equal to x square plus 2x plus 7. As you can see, that is the right logic. If you see the difference between a software engineering task and a machine learning task over here, in case of a software engineering task, you need to know the logic to be able to implement it. And given an input, the logic would get executed as a Python code, let's say, and you would get the output, exactly the output that is correct. But in machine learning case, we do not know what the pattern is. The entire objective is to identify the pattern by looking at lots of examples like this. So the model has identified the logic or the pattern as much accurately as possible. Now that I know that this is the logic, given x is equal to 7, now can I tell what could be the value of y? Absolutely. 7 would be given to the machine learning model, let us say, where 7 would be substituted in this particular equation and you would get the output as 70, which is exactly correct in this situation. I hope you have understood that the entire purpose of machine learning is to identify patterns by looking at the past data and use the pattern to be able to predict the future as much accurately as possible. That is the entire objective of machine learning. What is machine learning is that to be able to give machines the ability to learn. Now, did this machine which had this ML model internally, did this learn the relationship between x and y? It has learnt, and this is the relationship. So it has learnt. A human being has not learned the relationship and he did not write the code. That would be a software engineering task. Now this is what machine learning is, which learnt on its own the relationship. Alright, let us look at a little bit more complicated example, because in real life there will be a lot more complicated data patterns. Now if I ask you, can you find any pattern between, let us say, these three inputs, which are age, skills and experience, and this as the output, which is salary? Can you identify any pattern? Can you find that logic relationship? Well, it's very difficult to find, isn't it? It would take a lot of time. Maybe you might have to start a mathematical theorem or an objective, or you might have to use a lot of complicated functions and so on to be able to come up with an appropriate relationship. That also would take a lot of time. But a machine, on the other hand, can identify the pattern. But a machine, on the other hand, can identify the pattern in few seconds. Now, let us say the pattern is this, or maybe it could be this. It could be anything. That would be totally depending upon what are the numbers over here. So if you look, let us say age is 30 and skills is 5 out of 10 as a rating given. Experience the person is having is over 8 years, and the salary this person is getting is 30 lakhs. Salary is what is clearly dependent on his age, skills and experience. Now if this is the data given to us, and if we can see a pattern, can you identify what could be the salary that should be given if the age is 26, skills is 9 out of 10 as a rating, and 5 years of experience? So how many lakhs should be the salary? You can answer this only if you know the relationship as much accurately as possible. It could be this or this or this, whatever it is. Now that would be identified by a machine learning model. Let us say, for example, I have written Python code for linear regression. Now this linear regression code would actually take this as input. Now this linear regression code would see that if these are the inputs, this is the output. That is, it is learning that if a person is having 30 years of age and skills as 5 out of 10 and experience as 8 years, then the salary given is 30 lakhs. Similarly, if it is 27, 9, 3, it is 45 and so on. Now what is this linear regression code? A linear regression is a machine learning model which actually uses a lot of mathematics internally, and using which it is able to come up with a relationship like this. Now, is this an exact relationship? No, not necessarily. It would be always an estimate that would be given by the model. That is, it's only an approximate logic or an estimated pattern that would be identified. And this is the case in real world, because the patterns are a lot more complicated. Now, if the logic is identified or the pattern is identified, it is estimated. Let us say a new person comes up and you have to identify what could be the salary. Given 26 years old and 9 out of 10 is the skills and experience is 5, I would just give this to the machine learning model called linear regression, which has already figured out the pattern, and using that it will give me the estimate as 42 lakhs, let's say. and the actual offer made could have been 43 lakhs. And if you see here, there is a close, and if you see here, the prediction is really close to the actual offer made. It has done a very good job in predicting the salary given the candidate's age, skills and experience. Simply, all it does is substitute age 26 here, skills 9 here and experience 5 here to be able to arrive at this number, let's say. And it is very close to the actual offer made. So we would say the machine learning model has learned the pattern in a very good manner, and it is able to estimate and predict the target variable, which is the salary, in a very good manner. Great. Okay, so do you feel there is too much of information? Well, how about a joke? So let me ask you a question. What do you call a dog magician? What do you call a dog which can do magic? Can you think about it for a few seconds? It's called as a labracadabrador. I hope this is funny, and maybe I hope you find me funny or maybe not funny, but the credit should go to ChatGPT over here, because all I did was just search dog jokes in ChatGPT, and these are some of the jokes that ChatGPT has come up with, which is quite good. I have given this an example to make you understand the level of AI technology right now. Currently, AI is able to come up with jokes, write software code, write poems, solve problems, and do lots of creative tasks. That is where the AI is currently, and we are heading towards artificial general intelligence. But the starting of all of these is with machine learning, and especially with few basic machine learning models such as linear regression, decision tree and so on. Now, in the further classes, we will be learning about all of these models along with its mathematical foundation and practical application. Since we are in the topic of dogs, I thought it will be good if we look at some dogs and cute cats. Okay, so are you a dog person or a cat person? Do you find this cute? Now, let me ask you a question. Given an image, can you tell if the image has a dog or a cat? Well, of course you can. But if I ask you, can you tell me how are you able to do it? Maybe you might not be able to give me an accurate answer. Well, yes, you can say that, yeah, I think I look at the nose of the dog, or if it's a fluffy, maybe I somehow subconsciously look at the shape of the face of the animal. Maybe a cat has a different face, a dog has a different kind of a face and so on. Yes, those are all true. But can you tell me what is that exact logic or pattern or formula that is you're using inside your head, inside your brain, to be able to say that there is a cat or there is a dog? Well, we don't know that completely, isn't it? But you can definitely tell if it's a cat or a dog, right? But we do not know how we are doing it. When we don't know how we are doing it, then how can I implement the logic and then execute the logic to be able to tell if a given input is a dog or a cat? I don't know the logic, therefore I cannot implement it. As simple as that. Well, the logic could be something like this, where it is 50 into eyes diameter plus 30 into nose shape, nose color, lots of more complicated features will be included, right? Maybe you look at the color of the dog, the color of the animal, or whether it is having the tongue outside. A lot of factors can be taken into account. But we don't know the exact relationship or the exact logic. Therefore, we cannot implement it. But a ML model, let us say a convolution neural network model, can actually learn by looking at lots of images of dogs. It can learn the pattern of dogs. It can learn the pattern of cats. And the model would consist of lots of neurons and connected among themselves in a complicated manner. To be simple, internally it uses a lot of mathematics to be able to understand the pattern of dog and understand the pattern of cat. Once the pattern is understood, let us say by this model, as you can see its graphical representation, given an input such as this and pic of a dog to this particular model, it will be able to tell whether the image has a dog or a cat with a certain probability. Over here it is saying that the input has a dog with 95% probability and it could be a cat with 5% probability. Therefore, clearly this model has given accurate prediction that it has a dog. Now, how is this model able to identify the pattern? That is for the further topics to understand, which involves lots of mathematics and ways of learning patterns. Okay, now that we have seen a lot of theory about what is machine learning, it's time to get some action. Let's go to the Python environment and look at an example of machine learning task so that we clearly understand what is machine learning much better, because learning is of course ultimately a good balance of theory and practice. So let's consider two examples in Python environment. For example, if I give you a task, hey, given a number, can you tell me if it is even or an odd? It's a very simple task. Let's say I give you a number called 55. All you have to do is divide it by 2 and observe its remainder. If the remainder is 1, it's an odd number. If the remainder is 0, it's an even number. I have written a code for this because I know the logic. If the remainder is 0, it is even. Otherwise, it is odd. As simple as that. Now, when I run this and let us say I will give input as 33, the code is clearly telling me that the number is odd, which is correct. Now, let us say I will enter 46 and it is telling it is even, which is again correct. Therefore, since I know the logic of identifying if a number is even or odd, I have implemented the logic and I have automated it. But sometimes when I have data like this, it is not very straightforward to identify the logic. That is, I don't know the logic between salary and age, skills and experience. In such cases, I would build a machine learning model, let us say linear regression, where I have imported the model, I have created an object and I am telling to the model that these are my inputs or my X variables, which are age, skills and experience, and these are my output variable, which is salary. And I would just give this fit method, which would internally use a lot of mathematics and learn the pattern between input and output. And if you see, this is what is the pattern that it has learned. And if we express that in terms of equation, it would be this. Salary is minus 1902561 plus this into age plus this into skills plus this into experience. That is what is the relationship. Great. Now that I know the relationship, when a new person comes with a certain years of age and skills rating and experience, can I guess what could be his salary? Well, I can take this and I can give this to a model, which is in my case linear regression model. I will give it to the linear regression model which has already learned the pattern, which is this. Now using that pattern, I would predict. To predict, I would have to give the inputs. I have given the inputs and the prediction is, as you can see here, approximately 41,41,000, so on. So the prediction from here is that given this person's details of a certain age and skills and experience, this is the salary that can be offered. Well, isn't it great? Without understanding the relationship or logic between these, all I did was simply invoke a model, a machine learning model, which has figured out the pattern between this on its own. It has learned the pattern between inputs and output on its own, using lots of mathematics internally. And once it has identified the pattern, using that pattern I can predict for a person, for a new person with a certain input details, which is in this case 41 lakhs. That's it. Now this is the basic difference between software engineering and machine learning task, where in case of software engineering I have written the logic. In case of machine learning I have written the code. In case of software engineering I have written the code which is simply the logic, and in case of machine learning also I have written the code, but the code is of implementing the model which will figure out the logic on its own, which will learn the logic on its own, and using that we can estimate the output in this manner. Great, let's come back. All right, now we have understood what is machine learning, which is the field of study which gives the computer's ability to learn without being explicitly programmed. That is, we are not explicitly programming the logic because we do not know ourselves. Therefore, we are writing the code of machine learning models which will look at the data and it will identify the patterns, and from the patterns that it has learnt, it will estimate the future as much accurately as possible. For example, stock prediction, identifying if an image consists of a dog or a cat, what is the loan amount that can be given to this person given his, let's say, CIBIL score, age, salary, and so on. All these are examples of machine learning and many more. Okay, now that we have understood what is machine learning, the natural next question would be, how is machine learning model able to identify pattern from the data? How is it scanning the data and identifying the patterns or the logic accurately and using that predict the future? Well, to know that, we have to look at lots of exciting ways and approaches of learning which involves lots of basics of mathematics and statistics, and to do this we will be learning all of these concepts through lots of examples and analogies. So get ready to enjoy the process, where in the further videos we will look at the how part of machine learning, which involves lots of mathematics and approaches using which patterns are learnt from the data and using which the future is predicted as much accurately as possible. Well, that's all for this video. I will see you in the next video. Thank you.